Good afternoon, ladies and gentlemen, and welcome to a cool clip where we deal with why are SUMO and continuous beam moments different from each other. And this is specific to when we use the beam detailing design link from SUMO to continuous beam, we found that the M max values are different and considerably different. So in this clip, we will be dealing with that and explaining exactly why that is the case and how we can actually compare these moments with each other. My name is Jacobus Oberholster. I'm an AEC and Prokon technical consultant with Micrographics, and you can see my email address at the bottom left. And you're, of course, more than welcome to send me a mail if you have any queries. Otherwise, put them in the comment section below, and we will most definitely deal with that. So, right, without further ado, let's jump into it. So here we have our SUMO model, which we just have a slab with a monolithic beam. I've got quite a fine mesh, just that it makes it easier to read off of those graphs. And I've already run the analysis. So what I'm going to do is going to go to results. I'm going to look at beams and go to X moment. And we can see here, we zoom in at the middle here, our moments around 24.17, 24.22 if we're looking at a maximum value. All right, according to SUMO. So if we now go to design links, we go to beam detailing, select the monolithic beam. I'm going to make that 100% of these loads are permanent, these load effects, and click OK. Right, now we're going to go to continuous beam. I'll pull that one over here. And go to moments and shear. We can see here that the Mmax value is 139.9 kilonewton meters right in the center. And that is very, very different from what we just had in SUMO. So what I'm going to do is I'm going to close this. I have the previous one open as well, so I'm going to close both of those. And I'm going to show you how this is calculated. So the bending moment is calculated as the actual moment plus the axial force times the beam offset. Right, so if we try to read off the maximum value here, I'll probably make this a bit smaller. See if that helps. All right. So looking for the value, the maximum value, because we're looking at maximum sag, and we can see here that 330.56 is the maximum axial force. Right, so what we're going to do now is we're going to look at comparing that value with our calculations. Right, so we're going to move on from here, and we're going to calculate the M total. So that is equal to the M beam, which we read off from the results workspace, plus M axial. And M axial is equal to the axial force times the offset of the monolithic beam. Right, we have the value of 330.56. And out of SUMO, our monolithic beam was offset by 350 millimeters, or in this case 0.35 meters. And when we add those two together, we get a value of 139.87 kilonewton meter. Right. If we go back to our design link, we go beam detailing. I'll make this 100%. And we look at, again, M max, we'll see that the two are relatable. So if we go at moments shear, we see 139.9 is M max. If we go back to our calculations, we see 139.87, which is 139.9. And that is why your values differ between the two, because you actually need to calculate this M total value. So I hope that sheds some light on why your moments in SUMO initially seem different from your moment in continuous beam when you're using the beam detailing design link. And you'll find that this is the equation that you need to follow to create or to get the comparable values between the two. And you'll see that the value calculated in SUMO is exactly the same as the value that you find in continuous beam. So I hope that was helpful. If you have any questions, please pop them in the comments section below. Like and subscribe, and I hope to hear from you soon and see you in future clips.